Alrighty, gonna make this quick and just do those few questions that popped up. I should have got rid of this stupid message right here before starting, but whatever. So number 22, or the one between number 22 and 23. Okay, so this little number 5 over here. Phenotypically normal man who has a hemophiliac brother marries a homozygous normal woman. What is the probability that any of their children will be hemophiliac? So, phenotypically normal man, that means, again, this is sex-linked traits specifically. So, you got to figure out XX, XY first. XY for the man. He's phenotypically normal for hemophilia. That's big H is dominant. Normal is dominant there. Now for the female, he has a hemophiliac brother, which is nice for him, and marries a homozygous normal woman. So the woman, XX, because she's a woman, normal, and she's homozygous, so that means two big H's. So that's their genotype. Let's see if I could superscript this real quick. This question was lifted from a worksheet that I think period 1 started, but period 3 didn't get to see yet. I forget which one saw it and which one didn't. It might be the reverse of that. Anyway, it was lifted from a worksheet, and there was a question later about the hemophiliac brother. So that information is kind of a red herring, misdirection. You think it might mean something, but it doesn't mean anything for this particular question. It just means something for a later question on that particular worksheet. So we don't have to worry about the brother. Probability that any of their kids will be hemophiliac. Kind of impossible for me to do a Punnett square right now. But what you would do is you would have the top of your Punnett square be the male, and the bottom of your square be female. And you could see that no matter what happens, any child that they have is going to have the big H, which is the dominant allele for normal. So probability of a hemophiliac child? None. There's no probability of a little h. And number 24, tall is dominant to short. White is dominant to purple. Heterozygous parent mixed with a white pure tall parent. Okay, so this is a dihybrid cross. We're looking at two completely different traits inherited at the same exact time. We could use whatever letters we want. I'm going to go with big T equals tall and little t equals short. I'm going to go with W and P, capital letters, lowercase, like the same darn letter, so I don't want to use those. Let's use for white or purple. Use I. Capital I. Oh, no, that's not very good either. We'll use H. Capital H equals white. Lowercase h equals purple. Purple. Heterozygous person, which means big H, little h for color, big T, little t for height, is mixed with someone who's white. White is dominant, so and I should have written yeah, heterozygous parent mixed with a white. I should have said heterozygous white. That was my intent. And then pure tall. So heterozygous white, big H, little h, pure tall, big T, big T. So you're going to cross those parents together. And what you have to do is you have to FOIL those letters basically. all the possibilities of H's combined with T's. You have to put them together. So on the top of your Punnett square, big H goes with the first big T. Big H goes with the little t. Little h goes with that big T. Little h goes with little t. Those are your top of the Punnett square. On the side of your Punnett square, it's basically just h's with big T's. Because, let me finish typing. Because no matter what you look at here, big H could go with that big T or that big T. And that's what you have represented right here. Big H going with those two big T's. Or you could have little h going with those two big T's. And that's what you could have right there. And then you just have to fill out your Punnett square from there. And I can't really do that on the computer. But phenotype ratios of the possible offspring. Yeah, so you'd have to fill that out. Any questions based on that? Once you fill it out, I think from what I remember in class, everybody was pretty good about figuring out the phenotype ratios and whatnot. Phenotype is trait. And this is for period 1 and period 3, by the way. So like period 4, period 2, period 7, you don't have to worry about this. This is something we did not do for you guys. So period 2, 7, and 4, don't worry. And 6, don't worry about this. Dihybrid stuff. Alrighty. So with that out of the way, I'm going to go do what I do best, and that is rearrange the facial phenotypes of the denizens of Hades in a little game called Doom. And if anybody has any review questions, you could still pop in and ask me review questions while I'm playing. Alright. See you in a second.